In this segment, we're going to be talking about Cartesian coordinate systems. And in the context of that, we're going to be talking specifically about some two-dimensional equations that will be graphed into those coordinate systems. Now, if you've taken some advanced math, you know that there are actually three dimensions that we can visualize, and we call those the x, the y, and the z dimension. On the SAT, you're only going to be dealing with an x, y coordinate system. And what we're going to be talking specifically about are the equations of a straight line and the equation of the parabola. Those are the two different types of equations that will be graphed on a Cartesian coordinate system on the SAT. Okay, let's look at a slope problem now. Here we have a Cartesian coordinate system. We have an x and we have a y. And our lines down here below the x-axis, they give you 2 points on the line, this point here and this point here. Now, there's a fast way and a slow way to solve this problem. You could use the slope formula. That's the slow way. I'll show you that first. We'll just review it. Slope equals y2 minus y1 over x2 minus x1. And we could just plug these in. Our y2 over here is a minus 4, and our y1 is also a minus 4. And our x2 is a 2. And our x1 is a minus 3. Now that would equal, our denominator is going to be 5, and the top would end up being 0. And anything into 0 is going to be 0, so we know our slope is c. Now the way to do this so that it's fast, though, I don't even need to erase this, but let me just explain it to you. Anytime you see a line that is parallel to the x-axis, the slope is always going to be 0. And so how do I know that this is parallel? The reason I know it's parallel is because we got 2 points on this line, and each point is 4 units away from the x-axis. So by definition, it's parallel. And the parallel line has to have a slope of 0. Okay, let's take a look at a second slope problem here. In this one, they show you a slope example above the question. The question is, the graph above shows y equals 2x. Which of the following graphs represents y equals absolute 2x? Well, it's obvious when you want to check to see if a line is the slope. Our slope here, which is this coefficient in front of the x here, that's your m, is 2 over 1. That means a rise of 2 and a run of 1. And if you look here, every dot on here goes up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. So that's y equals 2x. But what is it y equals absolute 2x? Well, what it means is that when you're doing this, instead of just going up 2 over 1, up 2 over 1, you would be doing it, since the absolute value is either negative or positive, so not only do you have the positive dots that go up this way, you would have it would be going this way. It would be to the left, like it would be up 2 over 1 this way, up 2 over 1 that way, up 2 over 1 this way, and you end up with this V shape like this. It would be the same as this without the bottom part coming over here. And you look down through here, the only one that could possibly be that is B. Okay, here we have a parabola problem, and give you an example up here at the top. They say the graph of y equals x squared shown in the figure above. Well, which of the following is the graph of y equals, I'll write it bigger out here, minus x plus 3 quantity squared minus 4. Okay, there's several things you should look at. Number one, when you see a minus sign outside this, that means if I was to go ahead and multiply this binomials out, there would be a negative sign in front of our a coefficient. And anytime you have a negative a coefficient in that general equation, the parabola is going to open up downward. So it has to be one of these three here. It can't be these that open upward. So I'm going to just mark those out. Now it's between these three here. The other rule I mentioned earlier was that if there's a constant inside the parentheses, that determines which way it moves on the x-axis, left or right. And if it's a plus, it moves it to the left. So we know it has to, we can eliminate this one because it's moved to the right. So it has to be between these two. Now the difference between these two is we got a positive 4 here and a negative 4 there. Well, we can see this other constant is the one that moves it up and down on the y-axis, and it's a negative number, so it has to be D, and we can mark out E.